Unit 3, page 63. The idea of a percentile is the first thing we have to digest. The meaning of a percentile, one of the course learning outcomes. We start with that, and then eventually we make it to the box and whisker plot, a graphical representation. This is where we end up in Unit 3, a box and whisker plot, but we must start first by understanding the meaning of a percentile. What is the definition of a percentile? The kth percentile. A simple example of a percentile is the median. The median is the middle number of a data set. Half the data is smaller than the median, half the data is larger than the median. A number, the kth percentile. A number is the kth percentile if it is larger than k% of the data. The median is a number that is larger than 50% of the data, and so the median is the 50th percentile. The median is the simplest example of a percentile. If Fatma scored in the 85th percentile, we're not saying that Fatma scored 85%. This is not what we're saying. We're not saying this, we're saying her mark. Whatever her mark was, she scored in the 85th percentile. That means that she scored higher than 85% of the other students. And of course, that must mean that 15% scored higher than Fatma. 85%, 15%, 100% of the students, that is everybody. Fatma scored higher than 85%, but she scored less than 15%. That is the meaning of the 85th percentile. Now, we do use a formula. Here's the formula that Excel uses. It looks a little complicated. The first thing to note is that n is the position of the percentile we're looking for. Let's try to understand this formula with a simple percentile, the 50th percentile, the median. Let's look at an example of finding the median of some data. Remember, from Unit 2, we looked at the median. It's the middle number of a data set. Half the data is smaller than the median, half the data is larger than the median. If we say that half the data is smaller, we're saying that 50% of the data is smaller. The median is the 50th percentile. Now, of course, from Unit 2, we found it pretty easy to find the middle number of some data sets. If the data set is very small, 5 numbers, it is easy to find the middle. So we certainly don't need a formula like this to find the median the way we used to find it in Unit 2. But let us use this formula to understand how this formula works. So we're talking about the 50th percentile. We put 50 in for P. How much data do we have? 1, 2, 3, 4, 5 pieces of data. N is equal to 5. P is 50. These are the numbers we put into the formula. And we find N, 50 out of 100, times 5 plus 1 times 6. 1/2 times 6. 1/2 of 6 is 3. 50 out of 100 is same as the number 1/2. 50%, same as 1/2. What is n? Remember, n is the position. N is the position of the median. The median is in position 3. Where is position 3? Position 3 has the number 10. The median is equal to 10. So this is how we use this formula. Be careful not to say that the median is 3. The median is the middle number, 10. The position of the median, the position is 3. That's a fairly simple data set. And this is a fairly simple formula. If you're trying to find the 50th percentile, you put in 50 for P. If you use this formula, you have P out of 100 times n plus 1. The 50th percentile, 50 out of 100 times n plus 1. 50 out of 100 is the same as saying 1/2. 1/2 of n plus 1. The position is halfway through the data. We actually use n plus 1 instead of just n. Here we have n equals 5 pieces of data. But 5 plus 1 gave us the exact position, 3, 1/2 of 5 plus 1. What happens if we use this formula to find the median of data set B? What is the median of data set B? What is the middle number? What is the 50th percentile? Data set B does not have a middle number. There are 2 numbers in the middle. How do you find the median then? You remember from Unit 2, you had to add them and divide by 2. Again, the median of this data is the number 10. Half of the data is smaller than the number 10. 3, 7, and 8 are all smaller than 10. 12, 13, and 19 are all numbers that are larger than 10. The middle number, again, is 10. Here, 10 is a piece of the data. Here, 10 is not a piece of the data. The median does not have to be a piece of the data. The median is the middle number, the number which is at the 50th percentile. What does this formula say in this case? How many numbers do we have in this case? 6. N is equal to 6. What happens if we use this formula now? N, 1/2 times little n plus 1. 1/2, 6 plus 1 is 7. We get 3.5. That's an interesting position, 3.5. We don't have a number in the 3.5 position. In the previous example, in example A, we had a number in the 3rd position. 10 was in the 3rd position. But there is no 3.5 position. There's a 3rd position, there's a 4th position. What do you think the formula is trying to tell us? 3.5 position. Possibly is trying to tell us the number we're looking for, 10, is somewhere between the 3rd number and the 4th number. Maybe halfway between the 3rd number and the 4th number. That is how we use the formula. The position is 3.5. 3 plus 0.5. Break the number up into 2 pieces. 3 means the 3rd number. The 3rd number is the number 8. Plus 0.5 times, half times the distance. The distance to the next number. That is how we will use this formula. That is how we will use a position that has a decimal place. This is how Excel does it. The Excel formulas will give us the same result. The 3rd number is the number 8. Plus half halfway to the next number. What is the distance to the next number? From 8 to 12. Of course, you can do 12 minus 8. You can try to find the difference between 12 and 8. The difference is 4. So the distance to the next number is 4. We have the data 8. The next number is 12. We start at 8 and we go half the distance to the next number. 8 plus half of 4 is 2. 8 plus 2 is 10. The median is the number 10, just like we had before. Once again, you do not need to use this formula to find the median. We already knew the median, but this is how you use this formula. That's what we need to know.